Okay, let's get into this. If you've ever, plugged a screaming fuzz pedal into an old amp, or maybe just cranked up some single coils, you definitely know that sound, that constant hiss, that awful ground hum sometimes. It kills the silence between your notes. It's the worst.
It really is. It's like the enemy of dynamics, right?
Yeah.
You want your playing to stop clean. But we're not actually here today to talk about all the modern digital stuff for noise. We're actually going to dive back into some analog history. Find maybe the first great compact solution, the BOSS NF1 analog noise gate.
Yeah, this isn't just some random old pedal. This thing came out way back in 1978.
Yeah.
And the NF1, it holds this really key title. It was BOSS's very first noise gate in that compact format. It showed up just when analog gear was getting, louder and frankly noisier. Musicians really needed something reliable, something small like a mute button and a pedal.
Exactly. So our mission today really is to figure out how this early analog circuit tackled such a big technical problem back then, and also why its design choices, especially how it tried to keep your tone intact, why that made it such a trailblazer. It pretty much set the stage for what came next in noise reduction gear.
Okay, so its job seems pretty clear. Shut the signal off automatically when you stop playing,
Right.
when the volume drops below a certain point. But how did it do that smoothly? How did it avoid sounding like someone just, yanked the cable out the second your note started to fade?
That's where the cleverness of early analog design comes in. See, the NF1 is completely analog, no digital chips in sight. It works using this link system. There's an envelope detector circuit, and that controls a voltage-controlled amplifier, or VCA.
Okay, hang on. Envelope detector and VCA. So the detector, it watches my playing volume.
Yes, basically. It measures the amplitude, the loudness of your guitar signal, and then it converts that loudness into a control voltage.
So if I play louder, the voltage goes up, and if I stop or play really quietly, the voltage drops down.
That's the basic idea, and that changing voltage is what tells the VCA what to do. You can think of the VCA like an automatic volume knob, or maybe a faucet for your audio signal.
Okay.
When that control voltage is high, because you're playing loud enough, the faucet is wide open, your sound goes through. But as soon as your signal drops below the level you've set, that voltage falls, and the VCA starts to smoothly close that faucet, fading out the audio and muting the unwanted noise.
Right, which brings us to that core idea you mentioned, transparency. They really wanted it to be transparent. But wait a sec. If just cutting the signal off completely like a hard mute was possible then, why go through the trouble of using a VCA? That seems like the really crucial bit about the NF1.
It absolutely is. That VCA is the key to avoiding what engineers sometimes call a hard mute. That really abrupt, choppy cutoff, it sounds totally unnatural, kills your sustain. It's just unpleasant.
Yeah, nobody wants that.
Exactly. So the VCA, because it's controlled by that smoothly changing voltage, it gives you a much softer, more natural fade into silence. It's designed to be musical noise reduction, which was super important for players in the late 70s. They were really focused on protecting their core tone in those all-analog signal chains.
It sounds like they weren't just trying to kill noise. They were trying to, politely escort it out the door. Clarity without chopping your sound to pieces.
That's a great way to put it. The NF1 was definitely built for players who cared about how their notes ended, not just how they started.
Okay, so it sounds pretty sophisticated inside, with the detector and the VCA working together. But the real genius, maybe, was how BOSS boiled all that down to just two knobs on the outside. Super simple.
Simplicity really is often the best approach, especially on stage. You just have the sensitivity knob that sets your threshold level, and then the decay knob, which handles how quickly the gate actually closes.
Let's talk sensitivity first. That's basically telling the pedal, okay, how quiet does my signal need to get before you start shutting things down?
Exactly right. That sets the trigger point. So if you turn the sensitivity up high, you're telling the gate don't close until the signal is really quiet. That's important if you've got, say, high output pickups or maybe a distortion pedal that's always adding a bit of hum or hiss. You need the gate to stay open through that lower level noise and only close when your actual note truly fades out.
Makes sense. And then the decay knob.
Yeah.
That adjusts the speed of the VCA closing down. It sounds like where the actual feel of the gating comes from.
It really is. That timing is everything for the musicality. It determines if you get a nice, gentle, slow fade out or if it's a really sudden, sharp stop. Oh, and just from a technical standpoint, we should probably mention the standard power stuff. It took a 9V battery, or the old BAS ACA adapter.
Ah, the ACA adapter. Fun times.
Yeah. And it used Boss's standard buffered electronic switching, like most of their pedals then. And considering it was only made for about 4 years, 1978 to 1982, the NF1 really did establish the basic idea of a compact noise gate pretty quickly, even though it wasn't around for that long.
Only 4 years. Wow. Yeah, that definitely makes it a collector's item these days. But let's bring it back to like practical use.
Yeah.
If I'm playing modern high game stuff today, why should I care about this specific, 40-something-year-old analog pedal? What was it especially good at back then that might still matter?
Well, because the things it was good at are still problems people face today, especially if you like vintage gear or just cranking your amp really loud.
Right.
The NF1 was particularly good at cleaning up really messy fuzz sounds. You know how some fuzzo pedals just have that constant background roar?
Oh, yeah. Or dealing with those old, noisy single-coil pickups. They were everywhere back then. I remember my first real amp in like this terrible basement practice space. The 60-cycle hum alone between songs was just deafening. A pedal like this would have been amazing for managing those messy live rigs, too. Bad power, long cables.
It absolutely would have been because, look, the NF1 doesn't magically fix the source of the noise. It doesn't eliminate hum from bad wiring. But what it does is dramatically improve the perceived clarity by getting rid of that noise floor between your notes. Yeah. And the fact that you could tailor how the gate closed just using those two simple knobs, that's what made it work so well in the real world.
Right. So if I wanted, say, a smooth, classic, bluesy kind of fade on the end of a note, I'd set the decay maybe halfway, let that VCA close down gently.
Exactly. That gives you that smooth musical end to the note. Really nice for cleaner tones where you want sustain to feel natural. But what if you were, a hard rock player? Early metal, maybe. You needed that sound to stop instantly for tight, choppy riffs.
Ah, okay. So then you'd crank up the sensitivity so it triggers easily. And you'd shorten the decay time, make it snap shut.
Precisely. That makes the gate close much faster. You get those really tight percussive stops that you need for heavy, distorted rhythm playing. And the fact that it could handle both ends of that spectrum just with simple analog circuits is pretty remarkable for the time.
No menus, no digital screens.
It's proof that sometimes, really effective control doesn't need to be super complicated.
That flexibility is definitely impressive. But let's be real for a second. Technology obviously moved on. If the NF1 was so great at being transparent and musical, why did BAS replace it? Why did they eventually create things like the NS2, which became like the standard noise gate for decades? What were the limitations? What parts of it showed its age, being early analog tech?
That's a really important question. It gets right to the heart of why noise gate technology evolved. The NF1 definitely shows those trade-offs you get with early analog designs. Its strengths were clear. Simple controls, that really musical, natural-sounding gating action. And, of course, it was built like a tank in that classic BOSS enclosure.
Right, built to survive anything. But the weaknesses, that's why we have modern gates now, I guess.
Pretty much. The sources usually point to maybe 3 main limitations that pushed BOS towards their later designs. First, just a practical thing. No LED to show you when the gate was actually on or off.
Oh, right. Modern ones always have that light. So you were kind of guessing with the NF1.
Yeah, you had to rely purely on your ears. Second, its overall range of noise suppression was a bit limited compared to what digital gates could achieve later. It could handle typical hum and hiss pretty well, but maybe not, like extreme feedback squeals in super high gain situations.
Okay. And the third thing, you mentioned transparency was the goal.
Right. And this is the most interesting trade-off, I think. Despite that focus on transparency, that early analog VCA, it did introduce a tiny bit of signal coloration. It wasn't drastic, but it was there. That was the sonic compromise. The very part that gave it that nice musical fade also maybe added just a touch of its own character to the sound.
The classic analog paradox. You get the musicality, but maybe not absolute pristine neutrality.
Exactly. But still, we can't downplay its historical importance. The NF1 wasn't just a stepping stone. It really set the template. It directly led to every BAS noise suppressor that came after it. The NS1, the incredibly popular NS2, and even the fancy Wazacraft NS2W they make today.
So this one pedal basically defined BASS's whole approach to noise reduction for years and years. It proved that having a dedicated compact noise gate pedal was essential for cleaning up your tone, especially if you really cared about keeping your core sound intact. And I guess that unique musical way it closes. That's why collectors are still after the NF1 today, huh?
Absolutely. It's a cornerstone piece in the history of guitar effects, a simple musical answer to a common problem figured out decades ago using analog tech that was designed for a smooth flow, not just an abrupt cutoff.
A real testament to that kind of minimalist clarity-first engineering from BISS back then. Okay, so here's a final thought for you to maybe chew on after this. Today, we often rely on really precise, complex digital algorithms, right? We want absolute surgical silence between notes, perfect quiet. But the NF1, its whole strength was in the musicality of that analog VCA closure, that soft, natural phase. So the question is, does our modern pursuit of perfect silence sometimes make us sacrifice that more natural, transparent decay that a simple analog circuit handled so elegantly?
It's worth thinking about. When you dial in that super tight instant stop on your high gain rig, are you maybe losing a little bit of that musical breath at the end of the note? Something to consider the next time you hear that little bit of hiss start to creep in between chords. Welcome to the deep dive.
Okay, so our listener has sent us a really interesting set of sources this time, focusing on a piece of gear that looks simple, maybe deceptively simple, but it's just historically essential. We're talking about the BAW-SS NS2 noise suppressor.
Right.
And look, if you're someone who uses any kind of high-gain setup, think, screaming laid tones, maybe heavy rhythm sounds, or just pushing a lot of distortion, you definitely know the problem.
Oh, yeah. The hiss.
That constant high-pitched hiss, maybe some hum that just hangs in the air the second you stop playing.
It's the enemy of silence, really, and it can just muddy up your whole sound.
Exactly.
And that's precisely the problem. This little white box, the NS2, was built to tackle way back in, 1987?
Right, 87.
What's kind of amazing, though, is that now with all the digital tech, fancy modelers, super fast gates, the NS2 is still pretty much the industry standard.
It really is. You see it everywhere.
Yeah.
So our mission for this deep dive is to figure out why. Why does this relatively old analog pedal, which basically just tries to quiet things down, why is it still seen as such a technical achievement? It's clearly doing more than just acting like an on-off switch for noise.
That's the hook, isn't it? High gain naturally creates noise. We get that. The NS2 offers a way to deal with it, but it's dynamic. So how does it do that? What makes its core tech different, really different from just a basic noise gate that, clamps down hard when the signal gets quiet?
Okay, yeah, that difference is key. That's where we really need to dig in. A traditional noise gate, the simple kind. It basically works off a fixed threshold level.
Right.
Your guitar signal drops below that level, wham, the gate shuts, mutes the output instantly. It works, it makes things silent, but
it can sound really unnatural, right? Guitarists call it choking. It cuts off the note's decay too soon.
Precisely. You lose that natural ring out, that sustain. It's effective for silence, maybe, but not always great for the feel, the musicality.
Okay, so how did BSS get around that? How did they keep it musical while still killing the noise?
Well, they used a more sophisticated approach, architecturally speaking. Inside the NS2, there's an analog dual VCA design.
VCA, voltage-controlled amplifier.
Exactly. So instead of a simple switch just turning the signal off, these VCAs, they smoothly and dynamically adjust the amount of gain reduction. It's based on the level of the signal coming in. Think of it more like an attenuation circuit, not just a hard cutoff.
Ah, okay. So because it's using voltage to control the volume reduction, it can kind of fade the noise out instead of just chopping it.
You got it. That dynamic suppression lets it lower the noise floor smoothly without messing with the actual tone that's passing through at that moment. And this connects to a really crucial technical point from the sources. The detection circuit is separate from the audio path.
Okay, let's unpack that a bit. The audio path is my guitar sound, right?
Right, the actual sound waves.
So the detection path is listening to something else. What's it listening to, and how does keeping them separate help my tone?
It's listening to the envelope of your guitar signal. Think of the envelope like a graph showing how your note's volume changes over time.
The attack, the sustain, the decay.
Exactly. How fast it starts, how long it holds, how quickly it fades. The detection circuit uses that envelope information to tell the VCA when to start reducing noise and how much reduction to apply.
Okay.
Because the actual audio signal isn't going through that detection part, the NS2 can effectively work around your note, reducing the noise floor without touching the tonal character of the note itself.
I see. It separates the listening part from the sound part.
That separation is fundamental to why the NS2 has this reputation for being transparent. It keeps the full frequency response intact while getting rid of the unwanted hiss and buzz.
So that's the intelligence people talk about. It listens smartly without messing up the sound. Okay, so the VCA handles the smooth silencing, but the way you use it needs to be smart too. And I guess that brings us to probably the most famous feature, the thing that really made the NS2 stand out, that unique send return loop.
Oh, the loop. Yes. That was, and still is, a stroke of genius in terms of utility. We've established that the noise often comes from specific pedals, right? Your distortions, your fuzz boxes, maybe some noisy boosts.
Yeah, the gain stages.
If you just put a noise gate at the very beginning or very end of your chain, it's trying to clean up a signal that's already full of noise, often amplified noise. It's messy, less effective.
Because the noise is kind of baked into the signal by then.
Exactly. The send-return loop lets you basically quarantine the troublemakers. You physically isolate those noisy high-gain pedals inside the NS2's suppression circuit.
Okay, how does that work in practice?
The NS2 detects your clean guitar signal before it hits the noisy pedals. When you stop playing and that clean signal disappears, the NS2 then mutes the entire loop, cutting off the noise being generated by the distortion pedals inside it before that noise gets out to your amps.
So you're catching the noise right at the source within that loop. Genius. We see this setup everywhere now, but yeah, back in the late 80s, that must have been pretty revolutionary for a pedal.
Absolutely groundbreaking for a compact pedal.
So for someone setting up their board, what's the typical wiring for this?
It's pretty straightforward, but you got to get it right for it to work properly. Guitar goes into the main NS2 input jack.
Okay.
Then the signal goes out of the send jack through your chain of noisy pedals, distortion, overdrive, fuzz, whatever.
All the gain stuff.
Right. Then the output of the last noisy pedal goes back into the NS2's return jack.
Got it.
And finally, the now cleaned up signal goes out of the NS2's main output jack towards your modulation, delays, reverb, and then the amp.
So it creates this quiet little container just for the noise sources.
Perfectly put, a quiet container.
That makes total sense for killing that really specific hiss you get between notes, especially when you're playing tight, choppy riffs in like metal or heavy rock.
Yeah, give you that really tight percussive silence, but only if you dial in the controls right. Which brings us to the two main knobs you need to understand: threshold and decay.
Right, the threshold. That sets the level where the noise suppression actually starts working, yeah. What's the trick to setting that?
The trick is balancing it against your rig's overall noise floor and your playing dynamics. Set it too low, and it won't trigger soon enough. You'll still hear hiss leaking through when you stop playing.
Okay.
But set it too high, and the gate starts to think the tail end of your notes, as they decay naturally, is noise, and then it clamps down too early.
And you lose sustain. You get that choking effect we talked about.
Exactly, the very thing the VCA was designed to avoid. So you need to find that sweet spot where it kills the noise but lets your notes ring out.
Makes sense. And then there's the decay knob. That controls how long the gate stays open after the signal drops below the threshold. This sounds important for tailoring the feel.
Oh, it's crucial. Absolutely crucial for matching the pedal to your playing style or even the specific genres. If you're playing really fast, staccato, palm-muted metal riffs, you want that silence to snap back instantly between notes.
For maximum tightness.
Right, so you'd set a fast decay. If you set it too slow for that style, you'll hear the hiss lingering in those tiny gaps. Sounds sloppy.
Okay, but what if I'm playing, say, a blues solo with long held notes and I want natural feedback?
Then you need the opposite. You want the gate to stay open longer, allowing the note to fade out smoothly and naturally, so you dial in a slow decay.
Gotcha. Fast decay for tight, slow decay for smooth.
That's the essence of it. That flexibility, it makes the NS2 more than just a utility. It's almost a subtle tone-shaping tool in how it manages silence. And we should also mention the mode switch.
Right, the little toggle. You've got reduction, which is the normal operating mode.
Yeah, where it's actively suppressing noise. The little LED even shows you when it's working.
And then there's mute.
Mute is just indispensable, honestly. Live situations, studio work, hit that switch and it completely silences your entire output chain. Perfect for tuning up between songs, swapping guitars without pops, or just killing everything instantly if needed.
Super practical. And speaking of practical, we should probably mention the build quality. It's a BOSS pedal.
Meaning it's built like a tank, that classic rugged enclosure. You could probably drive a truck over it. And they added that handy DC out jack, too.
Yeah, the power pass-through lets you daisy chain power to another pedal or two. Seems small, but on a crowded pedal board, saving one power supply connection is actually a pretty big deal.
Oh, definitely. Simplifies your power setup, saves space, pure utility right there.
Okay, so let's circle back to the sound itself, the tonal profile. We established the VCA and separate detection path make it transparent. Why is preserving that full frequency response so important, thinking about both live playing and recording?
Well, noise is fundamentally the enemy of clarity of fidelity. In a recording context, any extra hiss or hum gets magnified during mixing and mastering. It's a pain to deal with later.
Right.
The NS2's transparency means you're feeding the recording system a clean, uncompromised signal from the start. And live, it's about reliability. When you need silence, whether it's the mute function or just the space between notes, you get actual silence, not some weird gated hum or artifact.
Okay, so use cases. We talked about the classic setup, putting the noisy pedals in the loop to kill hiss between notes. What about other ways to use it, like putting it right at the front of the chain?
Yeah, you can definitely do that too. If you place it right after your guitar before anything else, its main job becomes reducing noise originating from the guitar itself, like single coil pickup hum, or maybe noise from a long cable run.
Ah, so it cleans the signal before it even hits the gain stages and gets amplified.
Exactly. That can be useful even if you're not using super high gain. And for players with really complex rigs, maybe with MIDI switchers and tons of pedals, sometimes they'll use an NS2 near the end of the chain as a sort of master gate, a final cleanup stage to ensure the whole system stays dead quiet when it needs to.
So it's pretty versatile in its placement. Now, thinking about its legacy, this pedal landed in '87. Back then, wasn't serious noise reduction mostly found in big, expensive rack units?
Totally. If you wanted really good musical noise reduction before the NS2 came along in pedal form, you were looking at things like Rocktron's Hush systems, or maybe high-end DBX gates, big, expensive rack mount gear.
Stuff most gigging guitarists couldn't easily afford or carry around.
Right. The NS2 basically took that professional level efficiency and squeezed it into a standard compact pedal format. It made truly effective musical noise suppression accessible for the average player building a pedal board. It really set a new expectation.
And its design, particularly that send-return loop concept, clearly influenced what came later.
Hugely influential. Yeah, you can absolutely see its DNA in later popular noise gates like the ISP Decimator or MXR's Smart Gate. They took the core idea and ran with it. But arguably few have quite matched the NS2's specific combination of, simplicity, that analog feel in the decay, and just sheer reliability.
Which is probably why it's still considered the benchmark. And used by so many different kinds of players, right? Not just metal guys.
Oh, yeah. Of course, you see it on boards like Zakk Wylde's or Kirk Hammett's, but also players known for incredible precision and clarity, like John Petrucci or Andy Timmons. They rely on it for that tight, clean foundation.
That definitely speaks to its effectiveness across styles. But, like any gear, it's not magic. We need to talk limitations or maybe complexities. What are the main things users need to be aware of?
Well, the first thing is just taking the time to set it up right.
Yeah.
You really do have to carefully balance that threshold and decay for your specific rig and playing. Just plugging it in and cranking the knobs won't necessarily give you the best results. You might kill your sustain or still let noise through.
So user effort is required.
A little bit, yeah. The second, and this is really important for you, the listener, to grasp, it's a noise suppressor, not an electrical fault fixer.
Right. It doesn't fix bad wiring in the venue.
Exactly. The NS2 is brilliant at handling noise generated by your gear. The hiss from gain stages, pickup buzz amplified, but it cannot eliminate 60-cycle hum caused by bad power, ground loops, or strong radio frequency interference. That's a different problem needing a different solution, like maybe a power conditioner or checking your grounding.
Good distinction. It manages internal noise, not external electrical problems. And finally, there's the buffer question. Like most bias pedals, it uses buffered bypass.
Yes, it does, which is generally a good thing. That buffer helps drive your signal strongly through long cables without losing high-end frequencies.
But
For a very small subset of pedals, particularly some vintage fuzz circuits, they react differently depending on the impedance they see directly from the guitar pickups.
they like that direct high-impedance connection.
Right. Placing the NS2's buffer right before one of those specific fuzzes can slightly alter how the fuzz reacts, maybe make it sound a tiny bit thinner or less aggressive. It's a nuance point, mostly relevant for fuzz purists with very specific vintage gear, but it's worth knowing about. For 99% of setups, the buffer is fine, even beneficial.
Okay, so wrapping it up, the NS2 really does seem like a masterclass in, what did you call it, elegant utility design.
Yeah, I think that fits. It's simple on the surface, incredibly dependable, and highly effective at its core job, providing musical silence. It's a testament to great analog engineering, just lasting.
And it forces you, the player, to kind of prioritize, doesn't it? You're often choosing between that rock-solid silence the NS2 provides and maybe preserving the absolute theoretical 100% untouched interaction between your pickups and, say, a super finicky vintage fuzz.
It's a trade-off, and frankly, most working musicians, especially in loud, high-gain context, will take the reliable silence and utility the NS2 offers every single time.
Which brings us nicely to our final provocative thought for you, the listener, to ponder. We know the NS2 uses a buffer, which is generally great for signal integrity over distance, but technically alters the impedance seen by the next pedal compared to plugging straight in. So the question is, how much are you, as a musician, really willing to compromise that absolute, maybe theoretical transparency, that completely unaltered interaction for the practical, undeniable benefit of reliable musical silence and a strong signal down your cable run? What's the real-world cost of making noise disappear effectively in a live or recording setup? It's a fundamental engineering balance that plays out across your entire pedal board.
Welcome back to The Deep Dive. Today, we are taking a granular look at a piece of equipment that is, well, it's arguably the single most important utility pedal on any serious musician's board, the tuner. But we're not just, talking about tuning in general. We are plunging into the complete, almost geological record of the Bias S TU series.
Yeah.
We're talking the TU2, the TU3, the TU3S, and the Elite TU3W.
Yeah.
We're tracing the evolution of what really became the world standard for pitch detection on stage.
It's so easy to dismiss a tuner, right? It's just a simple necessity. But when you really spend time in the source material, the product engineering notes, the old gear reviews, the accounts from professional touring techs, the Boss S TU series, it reveals itself as this fascinating, 3-decade-long case study in product dominance.
Right.
This isn't just a list of features we're going through. It's a history of technological adaptation, and it's all driven by the brutal, non-negotiable demands of the professional musician.
So our mission today is really to trace this history, model by model.
Exactly. And to understand precisely why this specific line became the universal, unquestioned default for musicians globally.
We have 4 major models spanning from 1998 right up to the present day. So we're charting the course from the original legendary buffered workhorse, the TU2, which really defined the genre, then to the modern, globally recognized benchmark, the TU3. And finally, we get into the specialized variants, the Space Saver TU3S, which is designed for these really sophisticated routing systems.
Yeah, the modern book.
And the ultimate audiophile grade model, the TU3W Wazacraft, which it kind of attempts to resolve the biggest tone debate in pedal history.
Exactly. This deep dive is about more than just accuracy. It's about durability, it's about stage reliability, and the continuous evolution of signal integrity. The TU series literally defined modern pedal board architecture by addressing these critical needs. Not just tuning, but things like power distribution and signal preservation, often in the face of, really long cable runs and difficult stage conditions. We are going to unpack the specific innovations that made each iteration not just good, but necessary for its time.
Okay, let's unpack this and start at the beginning. 1998, with the release of the TU2 Chromatic Tuner. To really grasp its impact, you have to rewind to the era before it existed. What was the tuning situation like for professionals in the, say, mid to late 90s?
Oh, it was. It was a mess. The pre-1998 landscape was just fraught with compromises, especially for any kind of high-profile touring act. The primary challenges the sources consistently point to were threefold: visibility, ruggedness, and integration.
Okay, let's break that down. What do you mean by integration?
Well, if you wanted accurate tuning, you were often stuck with these delicate, expensive rack-mounted units.
All right, the big Korgs and things.
Exactly. Great for the studio, but just terrible on a stage floor. You're not going to put a 1U rack unit at your feet. So then the alternative was you might use these smaller, desktop-style chromatic tuners, which were never, ever designed to withstand being stomped on by a size 12 boot mid-set.
And crucially, visibility was a nightmare. I remember those old tuners.
Yeah.
Under the intense, varied lighting rigs of large venues, and especially outdoors during daylight festivals,
Yeah.
those small LCD screens or weak little LED lights were totally useless.
Completely useless.
You had to practically shade them with your body or your hand just to confirm your pitch. It was unprofessional and it was slow.
And that's where the TU2 just came in and immediately provided the solution. It offered fast, stable chromatic tuning encased in that now iconic signature Bias metal housing, the one we all know could probably survive a direct hit.
Yeah, the tank.
The tank. But the defining, market-dominating innovation was that emphasis on stage visibility. BSS didn't just add a few lights. They specifically engineered a layout of high-visibility red LEDs designed with the express purpose of cutting through direct stage spotlights and even direct sunlight.
So this wasn't an accident. It was a core design principle.
It was the design principle. This was a critical game changer. It addressed the musician's most fundamental need, knowing definitively if they are in tune instantly under any condition.
That instant confirmation under pressure, I mean, that's what separated the professional gear from the consumer gear, right? The historical impact was, frankly, astonishing. Sources discussing the TU2, they often use phrases like instant market dominance, and they note that it was seen on, this is the quote, virtually every touring rig from the late 90s straight through the 2000s.
Yeah.
This tells us that the TU2 wasn't just another pedal. It solved a persistent, widespread problem, and it established the foundational template for what a professional pedal tuner must be.
It completely normalized the idea that your tuner should live on the floor, be stomp-proof, and be usable anywhere. It's no exaggeration to call it one of the most culturally significant Bauhaus pedals ever produced. Not for its sound, of course.
No, not at all.
But for its reliability and its sheer utility, it became part of the infrastructure of live music.
So let's talk specifics. The architecture, core features, and, of course, the legendary debate that this pedal introduced to the masses, the bias buffer. What was actually happening under the hood of this thing?
Okay, so at its core, the TU2 utilized a dedicated digital tuning engine, and that was combined with that highly visual LED strength meter. For the time, the functionality was incredibly comprehensive. It had the standard mode button to toggle between general chromatic tuning or optimized modes specifically for guitar or bass.
Which was useful for slightly faster tracking on those instruments, right?
Exactly. It just helped the algorithm lock on a little quicker. And then you had the pitch button, which provided this vital utility for ensemble players, allowing you to adjust the reference frequency. It wasn't just stuck at A equals 440 hertz.
No, you could move it incrementally from 438 to 445 hertz. And that flexibility was crucial for working musicians who, they often had to match a non-standard piano in a club or maybe older orchestral instruments that weren't tuned to concert pitch.
Absolutely. And musically, as genres evolved toward heavier sounds, the flat tuning modes were indispensable. The TU2 was one of the first widely adopted tuners to support full drop tuning scenarios, allowing musicians to transpose their tuning down several steps without losing stability or pitch recognition.
And of course, the silent tuning, the output mute feature, the ability to check your tuning without setting a horrific E-string scrape through the PA system, that was revolutionary for onstage professionalism.
It was. It seems so basic now, but at the time it was a huge leap forward in stage etiquette and efficiency.
Now let's dive into the core of the controversy and really the strength of the pedal, the famous BSS buffer. The TU2 utilized a buffered bypass. So for listeners who might be unfamiliar with the concept, can you explain why putting a buffer and active electronic circuit at the very start of your chain was potentially controversial, but ultimately so beneficial for touring rigs?
Yeah, this is where the real depth of this analysis lies. The controversy, it all stems from the tone purist philosophy, which insists that any active electronics between the guitar and the amplifier will color the tone in some way.
And the preferred alternative for those purists is true bypass or TBP.
Right. True bypass uses a mechanical switch to completely remove the pedal's circuit from the signal path when it's off. It's like the pedal isn't even there.
But the buffer isn't inherently bad, is it? It serves a critical technical function.
Precisely. It's not bad at all. It's a tool. The BOS buffer is an impedance matching and signal conditioning circuit. So when you run a long cable, say 50 feet from your guitar, through 10 other pedals and then to your amp, that long electrical path introduces something called capacitance.
Okay, and what does capacitance do to your guitar signal?
Capacitance acts like a tiny passive filter that just rolls off your high-frequency content. It makes your guitar tones sound dull, muffled, and lifeless. It's often called tone suck.
So your beautiful, sparkling high-end detail, the chime and the presence, it just bleeds away into the atmosphere because the signal impedance from your pickups is too high for the length of the cable run.
That's exactly right. The TU2's buffered bypass, when you place it optimally right at the front of the pedal board, it essentially converted the delicate high-impedance signal from your guitar pickups into a robust, low-impedance signal.
It strengthens it.
It strengthens it. This strengthened signal could then travel through all those long cables and multiple circuits with minimal high-frequency loss. For a professional player with a large, complex touring rig, that stability and that guaranteed signal integrity were, they were arguably non-negotiable necessities.
Consistency, as you noted earlier, is king. A pro needs to sound the same in a small club as they do in an arena. The buffer provided that essential stability, ensuring the player sounded the same night after night, regardless of venue size or cable length.
Exactly, but the TU2 had another fascinating feature that pushed it beyond a simple utility pedal into a core organizational piece of the pedal board.
And that's the built-in power output.
That's it. The TU2 wasn't just a tuner, it was an integral power distribution hub. It had a dedicated 9V output jack that allowed it to daisy-chain power to other pedals on the board.
That is a detail that cannot be overstated for its convenience. For touring professionals relying on massive pedal boards, reducing the number of individual power supplies or wall warts or extra electrical sockets needed on stage, that was a huge logistical win.
A huge win. The TU2 became the electrical foundation stone of the board. It was often positioned first to maximize the benefit of its buffer and to serve as the power input point for the rest of the chain.
So it was the brain and the heart of the board in a way.
The sources really highlight how this multifunctionality solidified its indispensable status. The combination of bomb-proof construction, exceptional stage visibility, buffer-powered signal integrity, and that power pass-through made it the definition of a professional-grade solution.
Looking back, the legacy is just crystal clear. The TU2 shaped modern pedal board culture by establishing the template for stage reliability and all instrument tuning. But every groundbreaking product eventually reveals its limits. What were the specific trade-offs that eventually led BOSS to develop its replacement?
Well, after a decade of dominance, a few things started to show their age. The primary limitation was accuracy. The tuning engine, while very stable, operated at a tolerance of plus or minus 3 cents.
Okay, so plus or minus 3 cents.
While this was perfectly acceptable for standard live performance in 1998, as recording and mixing precision increased over the 2000s, the demand for tighter tolerance grew.
Let's put that into some real-world context for our listeners. Plus or minus 3 cents means a note could be 6 cents wide in its potential range of in tune.
Yeah.
In an orchestral setting, or a very specific studio session, 3 cents of inaccuracy on a single note can absolutely be audible, especially when that note is sustained or layered with other instruments.
Absolutely. For a piano, for example, 3 cents is often the difference between being perfectly in tune and having those subtle, dissonant beats or clashes, particularly in the upper registers. For solo electric guitar, it was fine. But for modern, tighter genres demanding perfect pitch, the tolerance needed to shrink.
And the buffer. We said it was revolutionary for high-end preservation, but the technology of the day meant that the TU2 did have a noticeable noise floor, didn't it?
It did. Compared to later BOSS generations and other premium buffers that came out, the TU2's buffer introduced a slightly taller, audible noise floor. It was particularly noticeable when your gain stages were high or when used with very sensitive, high-fidelity amplifiers.
You'd hear that little bit of hiss in the background.
A little bit of hiss, a little bit of ch. Its display, too, while groundbreaking in 1998, it became visually dated and less efficient as LED technology just rapidly advanced in the 2000s. It was a legend, but the stage was irrevocably set for a successor that could address these modern demands.
So 2009 arrives, and BOSS releases the TU3, which immediately took over the mantle of standard setter. The TU3 didn't just replace the TU2, it perfected the concept, and it remains to this day the most widely used pedal tuner in the world.
The TU3 is a masterpiece of refinement. It really demonstrates that BOSS was listening to a decade of professional feedback. If the TU2 was about setting the bar for rugged visibility, the TU3 was about setting the bar for clinical accuracy and visual intensity.
Let's start with that massive technical leap in accuracy. We moved from plus or minus 3 cents to plus or minus 1 cent. That is a threefold improvement in precision. What does that jump from 3 cents to 1 cent actually mean for the professional musician?
It means the difference between close enough for rock and roll and true studio-grade precision. When you are accurate to plus or minus 1 cent, the note is only 2 cents wide in its potential range, which is, that's virtually imperceptible to the human ear in live conditions.
So it takes any question of pitch out of the equation.
It completely removes it. This level of precision is necessary when multiple instruments are in play-like synths, acoustic instruments, or sampled sounds, all demanding near-perfect synchronization. This made the TU-3 not just a great guitar tuner, but a globally useful tool for all musicians requiring critical pitch accuracy.
And the display, the primary visual feature. The TU-2's red LEDs were powerful for their time, but the TU-3 ushered in a display revolution. It had a significantly brighter, densely packed 21-segment high-brightness LED meter. It just looked and performed like a truly modern piece of technology.
And crucially, it wasn't just brighter, it was smarter. The sources detail the inclusion of intelligent brightness adaptation. This isn't just turning the lights up or down, it's an internal mechanism that actively senses ambient light levels.
Oh, that's clever.
Yeah.
So if you're playing on a massive outdoor stage in direct sunlight, the LEDs automatically hit peak brightness to be visible.
Right.
Then, if the band moves into a dark, moody club or a studio, the LEDs will dim down appropriately so they're not blinding you.
Exactly that. This dynamic adjustment serves a dual purpose. It ensures maximum visibility in varied, difficult lighting, and it reduces eye strain for the user in dark environments. The TU-2 was a blinding beacon in a dark room. The TU-3 provided calculated optimal illumination. It solved the visibility problem definitively, regardless of the stage environment.
Beyond just visibility and core accuracy, the capacity of the TU-3 expanded significantly to reflect shifting musical trends. The 2000s and 2010s saw the explosion of extended-range instruments.
Big time.
7-string and 8-string guitars and 5- and 6-string basses.
That's a key detail that's often overlooked. Tuning a low B string, or even a low A string, is fundamentally difficult for a tuner that was designed primarily for standard guitar frequencies. These low notes, they have really complex overtones, and they often lack the strong fundamental frequency needed for stable detection.
It can make a tuner kind of warble or jump around.
Yes, that hunting behavior. The TU-3's enhanced engine was specifically designed to handle these low frequencies robustly and accurately. It officially supports 7-string guitars and 6-string basses, providing stability even at those extreme low-frequency vibrations.
So it wasn't enough to just recognize the notes. It had to lock on them instantly without the glitching or hunting that plagued older tuners when dealing with those low strings.
Right. And it also introduced new display modes that dramatically improved the user experience live. You had the choice between the classic scent display mode, which shows minute pitch variations via a needle,
The one we all
know, or the stream display mode, which provides a scrolling visualization of pitch fluctuation, which is great for identifying drift or seeing if a note is going sharp as you pick it.
But the feature that touring musicians really rave about, the one sources call extremely useful live, is the AccuPitch sign.
Yes. The AccuPitch sign is that unmistakable final confirmation. When the note is perfectly in tune, the display flashes, and it can also provide an audible beep if you want.
Right.
This sensory reinforcement is invaluable. When you are rushing between songs, trying to tune a guitar while the lights are dark and the crowd is cheering, you don't want to stare at a tiny line. You want instant, unequivocal feedback that says, stop, you're good.
The flat tuning modes expanded drastically as well. It now supported up to 6 semitones down.
Yeah, which is catering to the most extreme drop tunings required by contemporary metal and heavy genres. And thankfully, the crucial organizational utility remained. The power out jack for daisy chaining was fully retained.
So it preserved the TU-3's role as the power foundation of the pedal board.
Absolutely. It kept all the good stuff and improved everything else.
Now let's revisit the buffer. We established the TU-2 had a great buffer for signal preservation, but also a noticeable noise floor. The TU-3 features an improved buffer design. What specific improvements did Ballas implement to achieve a lower noise floor while retaining those signal-preserving properties?
It really comes down to a refinement in component selection and circuit design. The TU-3 utilizes more modern, low-noise operational amplifiers, or op-amps, and generally tighter filtering within the circuit.
So better parts, basically.
Better parts and a smarter layout. The goal was to maintain that low output impedance and high-frequency content strengthening, but to reduce the inherent hiss or background noise introduced by the active electronics. The sources all describe the TU-3's buffer as noticeably cleaner, ensuring better signal clarity and massive pedal boards without contributing that subtle whoosh or hum of the older design.
This is a critical distinction, then. They didn't abandon buffering, they perfected it. They recognized the practical necessity of the buffer for professionals running dozens of feet of cable, but they addressed the primary sonic criticism of the TU2.
Exactly. And this clean, consistent output is why the TU3 cemented its cultural status.
It is the undisputed champion.
Yeah.
I mean, since 2009, it has appeared on nearly every major touring musician's board and is rightly highlighted in our sources as the modern default tuner, likely the most popular tuner pedal of all time.
It's hard to argue with that.
Its reliability is legendary. You can drop it, you can spill beer on it, and it still performs perfectly.
Yet, even the benchmark has its trade-offs in a rapidly changing market. As pedalboard trends shifted toward ultra-compact design, the standard BiSS size, which the TU3 retains, became a consideration. It's significantly larger than the mini pedal format that just exploded in popularity over the last decade.
Yeah, pedalboard real estate became prime real estate.
For sure. And despite the vastly improved low-noise buffer, the TU3 still utilizes a buffered bypass. Even in 2009, and certainly today, there remains a dedicated faction of players, often those using vintage-style low-output pickups or very simple signal chains, who insist on absolute, true bypass purity.
That philosophical divide, buffer versus true bypass, it never went away, did it?
Not at all. Even though the TU3 provided the most reliable, accurate, and stable tuning experience the world had ever seen, and that unresolved debate, combined with the rise of complex routing systems, ultimately paved the way for the next stage of the TU lineage specialization.
The pedalboard world didn't stand still. As we moved into the 2010s, rigs got tighter and, more importantly, incredibly sophisticated. Programmable loop switchers and MIDI control became commonplace, turning a pedalboard from a linear chain of stops into this interconnected programmable network. This brings us to the adaptation phase of the BiSS tuner lineage, starting with the TU3S.
The TU3S, released in 2016, is a direct response to this architectural shift in pedalboards. If the TU3 was the professional workhorse for everyone, the TU3S is the professional system integrator.
What do you mean by that?
BiOS recognized that for a player using a master switcher like a Boss ES series or a similar competitor, the TU3's heavy-duty foot switch was, well, it was redundant.
Redundant and space-consuming. The modern pedalboard philosophy is all about minimalism and efficient use of that real estate we were just talking about. So what was the genius of the TU3S design?
The genius was stripping away the superfluous while retaining the critical technology. The TU3S uses the exact same core components as the gold standard TU3.
So it's the same brain.
It's the same brain, same eyes. The plus or minus 1 cent tuning engine, the intelligent brightness LED display, and the same clean, low-noise buffer. The key difference is the complete removal of the foot switch, which dramatically shrinks the overall footprint, significantly shorter.
And the smaller size allows it to be placed in tight spots, maybe tucked under a top shelf on a tiered board, integrated into a rack drawer, or squeezed into the tight loop of a programmable switcher where every single inch matters.
Its primary use case is always-on operation. When you use a programmable loop switcher, the switcher itself is what controls the mute and bypass function of your signal path.
Right.
The tuner is placed in a dedicated, isolated tuner output or a specific loop. This means the tuner doesn't need its own switch. It simply needs to be visible at all times, awaiting the external command from the switcher to mute the signal path for tuning.
This highlights BiOS as adapting to the modern touring methodology. Why stomp on the tuner when your central brain, the switcher, can mute the entire signal path with just one press, allowing you to tune silently while still seeing the display?
Exactly. It's optimization for efficiency. It's perfect for those complex rigs or even for studio musicians who just need a constant visual reference without worrying about accidentally clicking a switch during a take. The tonal profile is identical to the TU3, and it still has the power distribution capability and the same low-noise buffer.
But the trade-off is fundamental, isn't it? The T3S cannot mute the signal by itself.
No.
So if you're a standard 4-stomp box player without any external switching, this unit is essentially useless for silent tuning, as your signal is always passed through, whether you're tuning or not.
It's a very specific tool for a very specific type of professional, the systems engineer disguised as a guitarist. It showcases BiOS moving away from the one-size-fits-all model to providing tailored solutions for the highly demanding touring market.
Speaking of highly demanding, even while addressing space constraints, that tone purist debate never died. In fact, it probably intensified. Players demanded the incredible accuracy of the KEU platform, but wanted flexibility over the signal path. This brings us to the flagship, the technological pinnacle of the series, The TU3W Wazacraft, which was released in 2020.
The Wazacraft designation is huge. In the BAW-SS universe, Waza means art and technique. It signifies premium refinement, often involving hand-selected components and specialized circuitry designed to elevate a classic circuit into the elite category.
And the fact that BAW-SS chose their tuner as one of the Wazacraft projects is really telling.
It signaled that they considered this platform worthy of audiophile-grade status. It was about bridging that utility gap with absolute, uncompromising tonal integrity.
This unit exists, really, for one reason: to resolve that decades-long buffer versus true bypass conflict we've been tracing this whole time. The defining feature is the selectable bypass. How did the TU3W finally give players that ultimate choice?
It utilized a high-quality relay system that allows the user to switch between two distinct modes, effectively offering two different tuners in one box.
Okay, so mode 1. The true bypass mode. This is BAW-SS finally saying, for the purists, we concede. This mode removes all active circuitry when the pedal is off, achieving that absolute signal purity.
That's it. This is for the player using short cables, maybe just a few pedals, and who places that TBP purity above all else.
But the sources make it very clear that the real star here is mode 2, the premium Waza buffer.
Oh, absolutely. BAW-SS didn't just reuse the excellent TU3 buffer, they engineered a superior version from the ground up. It features enhanced clarity using higher-grade internal components, often metal film resistors and higher-quality op-amps. And the result is greater transparency, superior headroom, and an even lower noise floor than the already clean TU3 buffer.
Can you clarify the concept of headroom in this context for our listeners? What does that mean for a guitar player?
Sure. Headroom is essentially the amount of signal level margin you have before the circuit starts to distort or clip. A superior buffer with high headroom can handle hotter guitar signals, think powerful active pickups or high output humbuckers, without introducing any compression or unpleasant artifacts.
So it won't squash your sound.
It won't squash it at all. The premium Waza buffer is designed to handle virtually any signal thrown at it, reinforcing the signal path over immense cable distances with absolute sonic fidelity.
So if you were that professional running a huge stadium rig with, say, 150 feet of cable between your guitar and the amp, the premium Waza buffer ensures that the highest frequencies, all that sparkle and air, arrive intact and uncolored. It essentially removes the cable from the sonic equation.
It's the ultimate technical argument for buffering. And beyond the bypass choice, the TU3W includes an enhanced tuning engine. While it retains that same plus or minus 1 cent accuracy, the circuitry is tightened up to offer slightly faster detection and improved signal purity within the actual circuit itself. Objectively, it is the best performing, most flexible tuner BAW-SS has ever produced.
The use cases are crystal clear then. It targets high-end professional boards, studio environments where uncompromising accuracy and signal integrity are paramount. And most importantly, players who need the ability to A/B test their signal chain, maybe running true bypass for specific vintage pedals, then switching to the buffer for the rest of the chain. It gives you that flexibility.
The consideration, as always with Wazacraft, is the investment. It is the most expensive tuner in the lineup. And while the internal engineering is miles ahead, the visual experience, the display, and the ergonomics is intentionally maintained to match the TU3. The premium is solely about the audio pathway refinement and the internal performance upgrades.
So the TU3W is BAW-SS, recognizing the dual reality of the modern guitarist. The technical superiority of a great buffer for complex rigs, and the strong cultural insistence on having the true bypass option.
They provided both in the most pristine package possible.
What an evolution. It's rare to see a piece of utility equipment evolve so methodically, so logically, driven entirely by the increasing demands of the market. We've traced a history that spans from 1998 right up to the modern day, starting with those fundamental stage needs.
It's a perfect product lineage. To synthesize it all, the TU2 established the professional template. It focused on stage durability, high visibility, and that essential organizational utility of power distribution, operating at plus or minus 3 cents accuracy via the foundational BSS buffer.
Right, and then that foundation was refined into the TU3 in 2009, which defined the modern standard. It maximized accuracy to plus or minus 1 cent, introduced intelligent lighting, supported extended range instruments, and utilized a significantly improved low-noise buffer, cementing its status as the global default.
Exactly. And finally, we entered the age of specialization. The TU3S in 2016 prioritized compactness and integration for modern switching systems by removing the foot switch, optimizing for space, and always-on use.
And the TU3W Wazacraft in 2020 delivered the ultimate refinement with that selectable bypass, giving players the choice between absolute true bypass or the technically superior premium Waza buffer.
The TU series isn't just a tuner. It's a living document of professional pedalboard evolution. It reflects the shift from needing a reliable, visible workhorse in 1998 to demanding audiophile-grade tone integrity and tight logistical management in the 2020s.
And this continuous evolution, it circles back again and again to the core conflict we've detailed this whole time, the buffer debate.
It does. The sources clearly outline the undeniable, tangible technical benefits of the modern, sophisticated Waza buffer-enhanced clarity, better headroom, complete signal preservation over long distances. I mean, the technical case for the Waza buffer is incredibly strong.
So this raises a critical question for you, the player, to consider as you look at your own signal chain. Given the extreme technical superiority and surgical transparency of modern circuits like the Wazacraft buffer, is the search for pure true bypass in a modern rig still a choice driven by observable tonal integrity? Or is it perhaps a lingering philosophical preference rooted in avoiding the older, noisier buffer technology that plagued the pedal market 25 years ago?
It's a fantastic question. The TU3W offers the answer by giving you the choice. But the real question is, which choice do you truly need for your specific sound? What stands out to you about the necessary trade-offs in this remarkable lineage?
We hope this deep dive has provided the context to answer that question confidently for yourself. Thank you for sharing your sources with us for this exhaustive deep dive into the undisputed champion of pedal tuners. We'll catch you next time for another deep dive.